Hey, in this tutorial we're looking at section 7.7 on derivatives of inverse trigonometric functions. Okay, so just a bit of terminology that we've got to remember, okay, that we may not have seen before or not, and that's y equals inverse sine of x is the same as arc sine of x. Okay, inverse cos of x is the same as arc cos of x, and inverse tan of x is the same as arc tan of x. Okay, and for these we've got our domains and our ranges stated as well. Okay. If f of x equals inverse sine of x, then f dash of x equals 1 over the square root of 1 minus x squared. Or if f of x equals inverse sine of x on a, then f dash of x equals 1 over the square root of a squared take x squared. If f of x equals inverse cos of x, then f dash of x equals negative 1 over the square root of 1 minus x squared. And if f of x equals inverse cos of x on a, then f dash of x equals minus 1 on the square root of x squared minus a squared. Okay, for tan, we have if f of x equals inverse tan of x, then f dash of x equals 1 over 1 plus x squared. If f of x equals inverse tan of x on a, then f dash of x equals a over a squared plus x squared. Okay, so keep going on with our theory, and then we've got a lot of work examples to have a look at. Right, since sec of x equals 1 on cos of x, then inverse sec of x is equal to the inverse cos of 1 on x. Since cosec is 1 on sine, then inverse cosec is the same as inverse sine of 1 on x. And since cot equals 1 on tan, then inverse cot equals inverse tan of 1 on x. Okay, so to find f dash of x for our inverse cos, inverse cosec and inverse sec, we use the chain rule. Okay? And lastly, our second derivatives, okay, you'd think that these might be horrible, okay, but however, due to the form of the first derivative, they're actually not too bad. So, if we flip back for a second, really remember our second derivatives are going to be the derivatives of these things, okay, which aren't horrible. These are all pretty good, okay, to take the derivative of. So, we'll keep moving on, and we'll get stuck into our work examples. So looking at work example 25, and we've got if f of x equals inverse sine of x on 2, find f dash of x. Okay. We just need to do things with these ones about stating their maximal domain. So if you have trouble with a bit of that stuff, you might need to look back at the section on trigonometry, okay, just to do a bit of a refresher. Okay, but for y equals inverse sine of x on 2, okay, our domain, well, sorry, we can say it's defined for the modulus of x on 2 is less than or equal to 1. Okay, so that means that x is an element of minus 2 to 2. Okay, so we can use our rule for this one. Okay, so we can say our dy dx is equal to 1 over square root of 2 squared minus x squared. Okay, so we can say that that's equal to 1 over square root of 4 minus x squared. Now we say for x is an element of minus 2 to 2. Note that we had up here, sorry, that should be inverse. Okay, we had up here that x is an element of negative 2 to 2, okay, with square brackets, so we're including negative 2 and 2. But for our derivative, we can't include negative 2 and 2 because it's an endpoint. We can't take our derivatives of our endpoints, okay, because those points are considered not to be smooth. Okay, so for this one, okay, we say that, well, we're defined for, because we're 2x, we're defined for the modulus of 2x is less than or equal to 1. So x is an element of negative a half to a half. Okay, so for this one, okay, what we need to do, okay, is we're actually going to use the chain rule, okay, for this one, okay, because it doesn't quite work out the same. Okay, so what we need to do is say let u equal 2x. Okay, then we have y equals our inverse sine of u. We say well dy du is equal to our 1 over the square root of 1 minus u squared, and du dx is equal to 2. Right, therefore dy dx is equal to 2 over square root of 1 minus u squared. Okay, we can sub our u back in now and say that our dy dx is equal to our 2 over our square root of 1 minus, it was 2x, u was 2x, so 2x squared, we'll just take it as 4x squared. Okay. And we just need to say for x, so x is an element of, round brackets, negative a half to positive a half. Okay, so we'll keep moving on with our worked examples. Okay, so we've got a couple for inverse cos this time. Okay, so again we need to find what our domain is. So we say, well, the modulus of 2x on 3, okay, is less than or equal to 1. Okay, therefore x is an element of minus 3 on 2 and 3 on 2. Okay, again we're going to need to do a substitution here. And now we only actually have to do a substitution for the 2x. So what we'll do is we'll say let u equal 2x. Then we have y equals inverse cos of u on 3. Okay, so that's fine, we don't have any issues there. So when we do our dy du, okay, we can do that easily on this. We say, well, it's minus 1 over square root of this value squared, so 3 squared, which is 9, 8 minus u squared. We know our du dx is equal to 2. So bring them together. So dy dx is going to be our dy du times our du dx. So we're going to get minus 2 over square root of 9 minus, yeah, don't forget that our u was 2x, so we'll square that and make it 4x squared. Okay, where x is an element of our minus 3 on 2 to 3 on 2. Okay, and we're done. Okay, we'll keep working along up here for this next one. Okay, so again, our we just need to find our domain. So say, well, the modulus of 5x take 2 on 6, okay, is less than or equal to 1. Okay, so when we expand that out, we can say then that our minus 1 is less than or equal to 5x take 2 on 6 is less than or equal to 1. So we're just going to do a little bit more work on this one. Say then, well, we've got minus 6 is less than or equal to 5x take 2 less than or equal to 6. Okay, add 2 to both sides, we get minus 4 is less than or equal to 5x is less than or equal to 8. Okay, so we get then that's minus 4 on 5 is less than or equal to x less than or equal to 8 on 5. Okay, so we can say x is an element of minus 4 on 5 to 8 on 5. Okay, so I'll set this up for our domain later on. Okay, so what we do for this one is we say do our let u equal 5x minus 2. Okay, then y equals inverse cos of u on 6. Okay, when we do our du dx, that's 5. Okay, our dy du, well, that's going to equal minus 1 over the square root of this number squared, our 6 squared, so 36, okay, minus u squared. Okay, now we can times them together and say, well, our dy du equals minus 5 on the square root of 36 minus, well, u squared is all this squared, so it's 5x minus 2 squared. Okay, we do want to actually expand that out. Okay, well, what you can think of though is that we've really got the difference of 2 squareds here. Okay, so we say dy du is equal to minus 5 over the square root okay, of 6 plus 5x minus 2, okay, and 6 take 5x take 2. Okay, I'm just gonna, I'll switch colours just so it's clear where I'm going to here. So I'm just going to come up to here now, okay, because we can expand out these brackets, okay, and really say that we're dy dx, okay, is equal to our minus 5 over square root of, well, 6 take 2 is 4, so we've got 4 plus 5x times our, we'll take a negative, okay, so it's going to be 8 take 5x, okay, and then just leave it in that form, and we know that when, say, x is an element of round bracket this time, our minus 4 on 5 and 8 on 5. Okay. Alright, we'll keep moving on. Not surprisingly, we've got some inverse tan ones to have a look at now. Okay, so similar thing here. Okay, we're going to be saying, doing a substitution and saying, well, let u equal 3x. Okay, our du dx equals 3. We get y equals inverse tan of u on 4. Okay, so dy du, okay, for that is our, it's our a, this number, over a squared, which is 4 squared, which is 16, plus u squared. Okay, now we're going to multiply our du dx and our dy du together to get dy dx. Okay, well that's going to give us 12 over 16 plus, put in our u squared in, 9x squared. Okay, and we're done for that one. Okay, for this one, okay, we're going to do our let u equal 5x plus 4. Okay, so y equals inverse tan of u on 7. Okay, so we say our du dx, that's just going to equal 5. dy du, well, that's going to equal our 7 over 7 squared, right, which is 49 plus u squared. Right, we can times that our dy dx, our dy du and our du dx together. Get dy dx equals 35 over 49 plus our u was 5x plus 4 squared. Okay. So we're getting there. And then what we need to do is actually expand out our brackets on the bottom line. So dy dx is 35 over 49 plus, well, will be 5x times 5x, which will be 25x squared. Be 5x times 4, which is 20x, and we've got to times that by 2 to get 40x, okay, plus 16. Okay, so then we can say, well, that's equal to 35 over, well, our 49 plus our 16 is 65. So we can say we've got 25x squared plus 40, sorry, that should be plus 40x plus 65. Well, actually, we can see we can bring a 5 out here, okay, and cancel it with a 5 up there. So we can take that back to 7 over 5x squared plus 8x plus 13. Okay, and we're finished. Okay, so keep moving on. Our last two worked examples to have a look at. Okay, so for this one, we want to find our second derivative. Okay, so it's f double dash. Okay, so what we want to do, start off by doing our substitution. Oh, sorry, we need to start off with our sine one of 3x on 5 less than or equal to 1. Okay, so that means that x is an element of minus 5 on 3 to 5 on 3. Do our let u equal 3x, then y equals inverse sine of u on 5. So our du dx is equal to 3. Our dy du, okay, is equal to our 1 over the square root of 5 squared minus u squared. Okay, so our dy dx, bring them together, our 3 times it gives us 3 over square root of 25 minus u was our 3x, so that makes it 9x squared. Okay, so that gives us our dy dx. Okay, so now what we need to do is find our second derivative. Okay, easiest way to think about this then, we're saying, well, dy dx equals 3 times 25 minus 9x, 3 times 25 minus 9x squared to the negative a half. Okay, so that's just a simple chain rule question. Okay, so we go 3 times our negative a half gives us negative 3 on 2 times by derivative of what's inside here. Okay, we'll make our 2 comes down, so it makes it minus 18x. Okay, and then we've got times by 25 minus 9x squared to the power of negative 3 on 2. Okay, so when we do this, okay, we're going to get our 3 times 18 is positive 54, divided by 2 is positive 27. So let's say we've got 27x over the square root of 25 minus 9x squared all cubed. Okay, you could have technically gone the cube root of this squared. Okay, it means the same thing. Okay, but it's nicer not needing to have the cube root, just having the square root. Okay, and that's still for x is an element of our minus 5 on 3 to 5 on 3. Okay. Alright, so we're almost finished. Okay, we've got one last worked example to do. Okay, so we're saying if y equals the inverse cos of 3 on x, find dy dx. Okay, so to start off with, we need to go, well, modulus of 3 on x is less than or equal to 1. Okay, so negative 1 is less than or equal to 3 on x. Oops, 3 on x is less than or equal to 1. Okay, so when we do that, okay, we say, well, that, we end up, because we've got times across and then rearrange, we end up getting that x is greater than or equal to 3 and x is less than or equal to negative 3. Okay. So what we're going to do now is say, well, let u equal 3 on x. Now we've got y equals inverse cos of u. Okay, and we can say our u is equal to 3 x to the negative 1. And we keep moving on. And we can say then that our inverse cos of u, well, our dy du for that becomes our negative 1 over the square root of 1 minus u squared. Okay, and our du dx, well, that's going to be minus 3u to the negative 2. Okay, so we're getting there. We bring everything together. Sorry, that should be an x, not u. Okay, if you like, that's minus 3 on x squared. So we can multiply these together now to get dy dx. Our double negatives are going to make it a positive. 3 over x squared times the square root of 1 minus u was 3 on x, so then it'll be 9 on x squared. Okay. So what we can do is we can make that a little bit nicer and say, well, we've got 3 over x squared outside of x squared minus 9 over x squared. So that should be all in the under the square root sign. Okay. So we can simplify that. Now they do a little bit of a funny step here and say, well, the square root of x squared is equal to the modulus of x. Okay. So what they do is they split this up, okay, here over and make it the square root of x squared minus 9 over the square root of x squared, which is the modulus of x. Okay, so then they actually make it then equal to 3 times the modulus of x over x squared times the square root of x squared minus 9. Right, and then you can actually cancel down here with the modulus and x squared and make it 3 over the modulus of x times the square root of x squared minus 9, right, which is still for x is less than minus 3 and x is greater than 3. Okay, if you've gotten up to this stage, okay, and you hadn't gone any further, look, I'd imagine that that would be enough marks to get you what you needed on an exam. Okay, the only time that you'd probably need to take it through to this, from here to here, is if it's said to show it in a certain form. Okay, which I do like to do on exams, so probably still practice it a little bit, but it's definitely a bit of an odd example, that one. Okay, so that's all there is for this tutorial, so hopefully that's enough to get you through this section.